Today we're going to start a chapter on reasoning and proofs. Started this year letting you know that geometry is a little bit different. The system of geometry that we use is arbitrary. We pick the system. We can actually make up our own, as you've seen in taxicab space versus Euclidean geometry. We've also seen that there are other systems such as elliptic and hyperbolic that are valid. However, on good old flatland USA, straight lines, flat surfaces, Euclidean geometry works very well. Reasoning and proof. One of the things we have to do in geometry is we have to reason out situations based upon the definitions, the undefined terms, postulates that we have, and determine what is correct and what is true. So we're going to spend the chapter a couple of weeks on reasoning and proof to let you know what those rules are, and then we're going to start practicing those rules throughout the rest of the year on theorems, postulates, corollaries, and so forth. We're going to start chapter 2.1, section 2.1, and it is Inductive Reasoning and Conjecture. 2.1, Inductive Reasoning and Conjecture. We have some definitions we need to go over. I've written them up here. Stand back and read them. Conjecture is an educated guess based on known information. Okay? An educated guess based on known information. Something we know based upon a series of known information. Then we guess about what may happen in the future or what the next item or event will be. Now, inductive reasoning is reasoning or thinking that uses a number of specific examples to reach a plausible, another word for believable, generalization or prediction. Say it one more time. Inductive reasoning. It's reasoning or thinking that uses a number of specific examples to reach a plausible generalization or prediction. A couple of things. Reasoning is another word for thinking, how we think. To reach a plausible. Plausible would be a good word for believable, truthful, believable, generalization or prediction. In other words, we're just not guessing. We're not coming up with a conjecture that's just a guess. We're looking at events and we're looking at things and saying, based on this, we believe this will happen next. Based on what's happened in history, we believe this will happen next. Okay? And we'll do some examples of that and show you some of those. Okay, inductive reasoning and conjecture. Conjecture, an educated guess based on known information. Inductive reasoning, reasoning that uses a number of specific examples to reach a plausible generalization or prediction. Now, one other vocabulary word we need to get goes along with this, and that is counter example. Counter example is an example that shows the conjecture is false. Okay. Remember what a conjecture is. Conjecture is an educated guess based upon known information. So based upon historical information, you make an educated guess. Somebody comes along or something happens that says, wait a minute, here's one that doesn't fit that. This doesn't work. You look at it and sure enough, your conjecture or your educated guess based upon historical information doesn't look like it works in this case. Now, an example that shows the conjecture or educated guess is false is wrong. That's a counterexample. It only takes one counterexample to prove your conjecture or educated guess is wrong. That's all it takes. One. And we'll do some examples of that. Okay? Counterexample. One counterexample can prove your conjecture is wrong. So let's see what we do and how we make this happen. Got some examples we're going to do. First of all, I've got a series of numbers here. Let's put them up here. 5, 9, 13, 17. Now, based upon that information, can you give me a conjecture or an educated guess based upon known information, the numbers that are here, what's the next number in the series? Look at it. See what the pattern is. I'm sure some of you already got it. Yeah, hands up. Yeah. What is it? Well, what's the difference here? Plus 4. What's the difference here? Plus 4. What's the difference here? Plus 4. What do we expect the difference to be on the next one? We would expect the difference on the next one to be what? Plus 4. So the next item would be 21. Okay? This is our conjecture. This is our known information. Okay? So conjecture is an educated guess based upon known information. Pretty simple. Now, the process we used, the thinking we used, was inductive reasoning. Taking a number or several specific examples to come up with, or to reach, a plausible generalization or a prediction. In other words, we used these examples to come up with a prediction. Does that prediction work? Yeah. Can you predict the next one? The next one? Yes, you can. Okay, let's try some more. Let's look at some known information, see if we can come up with a conjecture. 0, 1, 3, 6, 10. It's our known information. What is your conjecture? What is the next number? What's your conjecture? What's your educated guess of the next number? What's the difference here? Plus 1. What's the difference here? That's right, plus 2. Difference here? Plus 3. Plus 4. What do you think it's going to be here? If we follow this pattern of known information, then we would say plus 5. And the next one would be 15. What would the next one be? Plus 6 and 21. Okay? Again, this right here is our conjecture. It is our educated guess. This is our known information. Okay? Okay? Now, I'm going to do one. I'm going to let you guess what it is. Try it out. Alright? Let's get some known information up here. See if you can come up with what the conjecture is. Our known information is, we're going to start with the number 1. The next number is 1/3. The next number is 1/9. The next number is 1/27. What do you think the next number will be? Here's our known information. What do you think your conjecture will be? Okay? Spell that right. Now, using inductive reasoning, taking several specific examples, 1, 2, 3, 4 different examples of what's going on, can you come up with an educated guess of what the fifth item is going to be? And the one after that, and the one after that. Can you come up with that? Okay? Try that. All right? Let me give you another one. Let's try this one. A little different. Start with 8. Start with, next one is 3. Next one, -2. Next one, -7. What's going to happen next? What comes after that? What is your conjecture? What's the next item? Based upon that information. Okay? Let's try another one. This time I'm going to draw a series of dots. I got 1 dot. I got 4 dots. I got that series of dots. What do you think the next one's going to look like? Let's put a comma there, a comma there, a comma there. What's the next figure look like? How many dots is it going to have? And what's it going to look like? What is your conjecture for this one? What's that going to look like? Okay? All right. Now, we've used series of numbers to find out what conjectures are using known information. Let's try it a different way. Let's come up with a conjecture about. Given a conjecture, let's see if we can prove it false or prove it true. See if we can come up with a counterexample. Here's our conjecture. The sum of 2 odd numbers is even. Okay? The sum of 2 odd numbers is even. This is our conjecture. Can we come up with a counterexample? Sum means what? So we're going to add what? 2 odd numbers to see if this is, it's another word for equals. So we're going to do addition of 2 odd numbers to see if the answer is even. Let's pick 2 odd numbers. 1 plus 3 equals, yep, that's right, 4. Oh, is that even? Yeah, it is. We'll pick another one. 3 plus 5 equals 8. Appears to be true. Well, let's try this. 1, 5, 6, 7. 3, 9, 2, 5. Oh, that's going to be a 2. Do we have to do anything else? That's going to be an even number, isn't it? Let's go on. This is 7, 8, 9. 5 and 9 is 14. Okay? So it appears that our conjecture is true. Okay? Now, can we do every example? No. But have we done enough to prove it? Is there a way that we can prove it? There is. Rather complicated. But we can do examples enough, and you have enough history doing addition. 2 odd numbers always comes up what? Even. So this conjecture we would say is true. Let's try another one. See if we can see one that's false. Come up with a counterexample. All right? The product of an odd integer and an even integer is odd. Okay? Let's write it down. The product of an odd integer and an even integer is odd. Okay? That's our conjecture. That's our statement. We think somebody has made a statement that says, based upon known information, the product of an odd integer and an even integer is odd. Okay? Product. We're going to do some multiplication, aren't we? Of an odd integer and an even integer equals an odd. So let's try one. 1 times 2 equals 2. Whoa! That's not true, is it? Do we have to do any more to prove that that conjecture is wrong? How many counterexamples does it take to prove a conjecture is wrong? 1 and only 1. This would be a counter example. We have taken an odd integer, an even integer, we've multiplied them, we've come up with 2. Oh, let's try another one just in case. We're not sure of that one. 2 times 3 equals 6. Whoops. Another counterexample. In fact, we're sort of we're proving the opposite. That the product of an odd integer and an even integer is, wow, we might change that conjecture to be something else. Try another one. 3 times 4 equals 12. 4 times 5 equals 20. 5 times 6 equals 30. Looks like we've begun to establish a pattern, and what we'd really like to say is we'd like to mark that out and change that conjecture to be that. Okay? So what we did was took our original conjecture, the product of an odd integer and an even integer is odd. And we said, let's see if we can prove it wrong. Sure enough, the first one we did is our counterexample. This is false because of our counterexample. How many counterexamples do we need in order to prove something false? We only need 1. Okay? Now, we'll do some that are a little bit more complicated. Take a little bit more work and effort. Because after all, you know, what we've done is just looked at math and algebra type stuff. Let's get into some geometric or some geometry conjectures and counterexamples. Okay? Let's take a couple. See if we can prove them true or see if we can prove them false. Alright? Let's write this one down. Given. Sometimes the conjecture is written that way. Given. And we'll put a colon there. And we'll say this. Segment AB is congruent to segment BC. Okay? That's our given or that's our statement. That's our known facts. We're going to come up with a conjecture or based upon that an educated guess. If you were to see this right here, segment AB is congruent to segment BC. Well, you know, this is one picture, so the point B has to be the same, right? You might come up with a conjecture that says this. B is the midpoint of segment AC. Let you look at that for a minute. Have a given statement. Segment AB is congruent to segment BC. You look at it and go, oh, because that's true, B has to be the midpoint of segment AC. It's between the two. Has to be that way. Okay? It's the only way you can see it. Can we possibly come up with something that would be a counterexample? Let's make some possible drawings and see if that makes it work. The one that all of us are thinking of is we'll see this right here. We'll come here. We'll see A here. We'll say C there. C there. B there. We say that right there. Proves our point. B is a segment bisector. Cuts segment AC in half, creating two congruent segments. Point proven. Finally, somebody else comes up and goes, oh, wait a minute. I know an example, and I'll draw one. See if this works. Come up. You have segment AB and you have segment BC. Segment AB is congruent to segment BC. But is B the midpoint of segment AC? What would we have to do? We'd have to draw segment AC, wouldn't we? If we can get it straight. We'd have to draw segment AC. Wow. Point B is not even on segment AC, is it? So how could it be the midpoint? Okay? This would be a counterexample. Counterexample proving this conjecture was false. Okay? Because of the counterexample. All right? Let's try one more. I'll leave it with you and see what you come up with. One more geometric conjecture, information given, and see if you can come up with a counterexample. Given points A, B, and C are collinear. All right. Conjecture. A, B, the measure of segment AB, plus the measure of segment BC equals the measure of segment AC. Okay? Can you give a counterexample to that? Can you draw something that would show this is not true? Based upon this right here, points A, B, and C are collinear, they're making the statement. We believe that segment AB plus segment BC is segment equals segment AC. See what you can do with that. Welcome to Inductive Reasoning and Conjectures. We do it all the time. You do it on Friday night and say, based upon what our history of the football team, we believe that this is going to happen. Based upon the performance of a certain volleyball team and volleyball player, we believe this is going to happen with that team. Okay? Based upon that person's driving record, we believe they're going to have a wreck. Based upon that person's history in math, I'm going to copy his homework. Why? Because he gets good grades. Has a history of it. So you always use this. Based upon what I know about my mom and dad, I know what their reaction to what I did is going to be. It's not going to be a good weekend. Okay, so you use inductive reasoning and conjecture all the time. We just call it different words. Okay? One of the things I like about geometry is taking what you already are doing and explaining it to you in terms mathematical that we use that you're going to see for the rest of your life as you go through school. Okay, what I'd like to do is left you with some questions in section 2.1. So let's go back and give you some answers. See if any of you did them. And go from there. Okay? I think the first one was this one. 1/3, 1/9, 1/27. What's the next one going to be? What did we do between here and there? We multiplied by what? 1/3. What did we do between here and here? We multiplied by 1/3. What did we do between here and here? We multiplied by 1/3. What do you think we're going to do here? Well, it sort of looks like we're going to multiply by 1/3. If we do that, what are we going to get? Come on, calculator. Put it to it. 1/81. Okay? Answer to that one. Alright? Now, let's look at another one. I think I left you with this one. Start with 8. Start with 3. -2. -7. Okay? What are we going to do with that? Well, what do we do here? Looks like a minus, well, not -3, it's a minus what? -5. What do we do here? -5. What do we do here? -5. What do you think we're going to do here? -5. If we do a -5, what's this one going to be? -12. So your conjecture is -12, based upon known information. All right? It's our second example I ask you to look at. Let's take the next one. Pretty sure y'all got this one. Add dots. There's one dot. And we had 4 dots. Can't have any spare dots on here. You want to know what the answers are. Now we have 9 dots. Start down here. Well, that's 1 squared, isn't it? 2 squared. 1 squared. 2 squared. 3 squared. What do you think the next one's going to be? 4 squared. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. What's the next one going to be? 5 squared, so forth and so on. Okay? All right, let's see if we can come up with another one. All right, left you with another question. Okay, let's go back to this one. Given, whoops, let's get an N in there. Points A, B, and C are collinear. Conjecture. AB plus BC equals AC. So, given the information that points A, B, and C are collinear, collinear meaning on the same line, then it has to be true that the measure of segment AB plus the measure of segment BC equals the measure of segment AC. Can we prove that true? Well, in order for that to be true, let's draw us a segment. AC would have to be there. Well, let's not put that in the middle. We wouldn't want to show that off, would we? We would make it a midpoint. Let's put it right there. A, B, and C are collinear. Well, let's get us a line there instead of whatever. Oops, still not very good, but let's go with it. We'll put B down here. Are A, B, and C collinear? Yes, they are on the same line. Is B between A and C? Yeah. So therefore, segment AB plus segment BC equals segment AC. Very good. Is that the only way we can draw that picture? Does points A, B, and C have to be in that order? No. Let's draw them in this order. C, A, and B. Are points A, B, and C collinear? Yes, they are. But is this true? No, it's not. In fact, down here we would say segment CA plus segment AB equals segment CB. This right here is what we call a counter example. How many counter examples does it take to prove a conjecture false? One. This conjecture is false. A, B, and C don't have to be in order. They can be out of order. Okay?